Hey everybody, welcome back. Hope you all had a good spring break. I have got the data for you for the MGT 291 project, so just want to create this video to give you something you can always revert back to get an idea of what all this data means, so that as you get deep into your analyses, you'll have something that you can make sure that you're clarifying what everything is and where it came from. So that's the goal of this video. This data file that will be attached in the Canvas announcements. First row is the variable names, and I'll walk you through what these are one at a time, and then give you a few other tidbits. So start date, that's probably not too important. Progress, not everybody filled out the entire survey. I'd say there's, I don't know, 20 or so that only filled out one or two measures, which is fine. Duration, if you wanted to only include or exclude certain number of a certain number of cases based upon how long it took them. So for example, these clearly were short because they didn't fill out the entire survey. But there might be a few, like this one, right? So they did all of their survey, but it didn't take them very much. This is seconds. So, that's 4 minutes to do that entire survey. So you might want to do some analyses and figure out whether or not those should be included. My recommendation, and we've covered this in class, is that figure out what the median is for anybody that completed the whole survey. So don't include those that are under 100%. Find the median and then use standard deviations. So if they're 1.5 standard deviations below the median, that might suggest that you might want to exclude those cases, because if they did it that fast, they probably weren't answering correctly. So something to consider in your analyses. Response ID, this is just a unique identifier created by Qualtrics. That's should be your all's names based upon the person that filled out surveys for you. You don't really need that. That's more giving high fives to everybody that was able to help out. The title of the individuals that filled out the survey. So this, I would suggest doing some type of thematic analysis to get an idea of what type of participants we had. From what I can tell, it looks like a pretty high level overall high level titles, right? We got some CFOs, we got managers, senior directors, senior vice presidents. So you should be able to describe that in your in the sample description for your methods section. So do some type of thematic analysis there to get a feel for what these titles are. Hours. So this is supposed to only be for full-time employees, and if they're only working 8 hours a week, 10 hours a week, 20 hours a week. Usually the cutoff is 30 hours a week or more to even be considered full-time. So this is another thing that I would suggest potentially filtering out. Just like you filter out those that maybe took this too quickly, you might also want to filter out, or said differently, run the analyses two different ways, with and without these individuals that technically are only working part-time, if that, right? So an 8-hour-a-week cook at a restaurant doesn't really count as a full-time employee. And that can skew your results in a big way, right? That's not the population that we're really evaluating. Employee age, we have a requirement that everyone is 18 years or older, so that's good. Supervisor age, making sure that fulfills our requirement. Yep, everybody's over 18, that's great. So years with their manager, and so for example, 0.5 means 6 months. Years with the organization, right? So they've been with their manager and their organization for 6 months. Employee gender, so 0 equals male, and it's in here as part of the variable name. Gender 1 means female, so male, female, male, female, female. And then there are a handful that are 3s. Those are non-binary. So you, again, will have some decisions to make. Do we exclude the non-binary handful altogether, or anybody, or any dyad with a non-binary, because that, let's see how many are in, let's see how many are supervisor non-binaries, right? So we got even more. So it's up to you. Do you think these should be excluded or included? Does gender identity make a difference for your analysis? If it does, then you might want to play around with it. If it doesn't, then you make some arguments as to why it's fine to include all sorts of gender identification. Ethnicity, I think you can do this in Excel and just total it up and have the proportions, or there's a feature in JASP that allows you to do this, but vast majority are white, like 76%. I did the analyses very quickly, and then next highest proportion looks to be Asian. This is education. You can do, again, another categorization, look at the proportions. You might want to do a thematic analysis for industry. You might want to total up one of the three, so either they're not a manager, they're a manager, or they're a manager of managers. And you can find these in the document that I sent your way that was the final measures, or within the survey itself, right? You can go back in and pinpoint what all of this stuff means. But so far we've just talked about like sample characteristics, and you're going to be responsible for reporting on what are the characteristics of the sample. How many do we have of different types within our data set, and then also making theoretically and logically sound decisions on whether or not to include or exclude different populations or characteristics within your analysis. Then we get to the fun stuff. So now we have the actual variables. So SP stands for supervisor. EE, so here's an example, EE stands for the employee. So this is supervisor's expertise. The reason this is important is because there's also an employee version of expertise, right? So this helps keep it straight. So if the employee was rating something about the supervisor, SP. If rating something about themselves, EE. So this is supervisor expertise. Supervisors, I forget what we called it in the actual data file, perception of leaders, promotion, acceptance of work-family balance. I call that work-family values, WFE, in the data set. And then this one, perception of leaders, promotion, acceptance of virtual work. I'm just calling that remote, just to keep it simple. So remote preferences, or whatever you want to call it. Supervisor advocacy, supervisor materialism, that's the one I just showed you. Supervisor's work-family values, or the correct terminology, perception of leaders, promotion, acceptance of work-family balance. So this is just a much shorter way to call the variable. Supervisor psychological capital, PSYCAP. Supervisor reward power, legitimate power, coercive power, referent power. And then we're getting into some employee variables. So employee self-esteem, employee's version of work-family values, employee PSYCAP, employee materialism, employee remote, employee expertise. And then we're getting into the dependent variables. So the last four here are these dependent variables. So the employee's ratings of the supervisor's performance, the employee's ratings of their satisfaction with the supervisor, the employee's ratings of their respect for their supervisor, and the employee's ratings of their LMX, or leader-member exchange, or relationship quality with their supervisor. So those are all the actual variables that you should be investigating for your direct effects. So independent variable is positively or negatively related to your dependent variable, as well as for your interactions. So for your moderation hypotheses, where you're in JASP creating those interaction variables. So we've covered the moderation, but then we also have item level data in here as well, right? So for example, supervisor expertise _1, 2, and 3. So 3, 3, and 4. This specific row is one case, and this person gave this a 3, this a 3, this a 4. So they said neutral, neutral, agree for supervisor expertise. That is simply, or this number is simply, the average of those three numbers. So 3.33 is the average of 3, 3, and 4. All right, so I created all of these variables for you, just taking the average of all of this item level data. And so same thing happens here. So we had 1, 2, 3, 4, 5, 6, 7 items that were representative of supervisors' preferences for remote work, and I just averaged those numbers 1, 2, 3, 4, 1, 2, 3, 2.49, 2.83, etc. One thing you'll notice for the remote, I know this only applies to maybe one group, maybe a second group, I think only one, is that the remote for supervisor rated and employee related, the first 3 items were positively rewarded. The last 4 items, 4, 5, 6, and 7, you'll see this number, or you'll see an R after the number. And that's because I did what's called a reverse code. So the way that these were worded, I'll show you here, 4, 5, 6, and 7, my leader believes teleworking decreases mutual learning, decreases cooperation, leads to isolation. So those are negatively worded. So what you do is you flip the score. So if they gave it a 1, I turned it into a 5. If they gave it a 2, I turned it into a 4. If they rated it a 4, I turned it into a 2. If they rated it a 5, I turned it into a 1. So for remote work, employee and supervisor, those have already been reverse scored at the item level, so that when I do the aggregate, where's the aggregate number, for supervisor remote, it's all going the right way, right? You got to make sure they're all positively rewarded or all negatively rewarded. So that's the only variable in this data set where that was necessary. All right, let's see what else we have. So after remote work, we have 4 items for advocacy, 1, 2, 3, 3 items for materialism, 4 items for work-family values, 1, 2, 3 for SciCap, and then there's 3 for each one of these different types of power. So reward power had 3, legit had 3, coercive 3, referent had 3, and then supervisor attractiveness is a 1-item scale. So there's the item level is the same as the construct level or the latent levels, right? It's just 1 item, right? And then work-family values had 1, 2, 3, 4, had 4 items. Self-esteem had 3 items. SciCap has 3 items. Materialism, attractiveness, remote, same thing here on the remote, right? So the 4 through 7 were reverse scored. Let's see what else is new. Expertise. Then we're getting into our dependent variables. So supervisor performance, 1, 2, and 3, and 4. Satisfaction is 3 items. Respect is 3 items. LMX is 7 items. All right, so those are important because you're going to have to run your reliabilities. You're going to have to make sure that, just as an example, hey, these 7 items are appropriate for aggregation, and then using that aggregated variable, which we looked at the beginning of the data set, is appropriate, right? So if you do your reliability analysis and it shows that, hey, item number 6 is really bad, and if you were to exclude this item, then your Cronbach alpha would go up to 0.7 or higher, well, then you might need to recreate your variable. And so to do that, you're going to have to get your Excel skills out and create a new variable that is a mean based upon 6 items in that example, right? So some of you might need to recreate variables, and you won't be using the ones that I've created for you here. You're going to have to make your own to correct for some of the challenges with the data. Okay, other important stuff. So for those of you who have congruence hypotheses, so for example, you were saying at high levels was going to be different than low levels, or low-high versus high-low, when you were looking at the joint effect of 2 different variables. So I think there was only 5. So expertise, remote, materialism, work-family values, and SciCap. So for those 5 variables, there was congruence hypotheses. So these are a little bit unique, and I had to create unique variables specific to just those congruence hypotheses. And we can walk through this in more detail later when we're starting to run those analyses. But in order to create those 5 terms, you have to have the employee effect, the supervisor effect. You have to have the squared term of the employee, the squared term of the supervisor, and the interaction of the 2. So there's 5 variables that you're plugging into a regression model, and then you take those 5 regression coefficients and plug them into that fancy spreadsheet that creates the plot. So those 5 variables I've created for you, and they're all based upon centered values. A centered value is simply taking